Okay, so we are going to do 10.5 today. We're going to do 10.5 pressure and stress. Pressure and stress. Yeah, so I think this is the longest chapter you guys have, the longest session you guys have, all right? So we're going to talk about pressure and stress. Let's talk about pressure first. Pressure is force divided by an area. In other words, force per area, right? Common units. Anybody have common units for pressure? The most common one that you use all the time is, PSI, right? PSI, pounds per square inch, right? Pounds per square inch. And tell me any kind of pressure you guys know. What do you guys know? What have you guys heard of? What have you dealt with? Pressure inside a tire, right? Yeah. You have to measure it. You got to take that little stupid thing and you press it and it pops out and tells you what the pressure is, right? Anybody done that before? Everybody done that before? Yeah. Right? Okay. Atmospheric pressure. Anybody heard the term atmospheric pressure before? So you learned this in chemistry, right? In chemistry, you are taught that. In chemistry, what's the definition of a mole? Oh, Avogadro's number, right? Avogadro's number, 6.022 times 10 to the 23rd, right? What does this mean? What is this?
The number of atoms in a mole.
Number of atoms in a mole, correct, right? Very good. The number of atoms in a mole at STP, at standard temperature and pressure. Okay, at standard temperature and pressure. What is standard temperature? Yeah, 25 degrees Celsius. Okay, 25 degrees Celsius, all right. What is standard pressure? Standard pressure is the atmospheric pressure at sea level, which is 14.7, good. 14.7 PSI. Okay, so if you went to sea level and you measured the atmospheric pressure, which is the pressure that is acting upon you, right? If you were at the beach at sea level, right? And if you looked at this, all the atmosphere that is pointing down, pressuring your head, if you added all that up, it would be 14.7 PSI, and that is what we call atmospheric pressure. Okay? So the mole, 6.022 times 10 to the 23rd, at standard temperature pressure, standard temperature being 25 degrees Celsius, pressure being 14.7 atmospheric, okay? Atmospheric pressure, right? Okay, so that's PSI, all right? That's one. All right. A couple others. There's a Pascal. What else are we talking about here? There's a Pascal. Okay, we talked about atmospheric pressure. We talked about that. Pascal. A Pascal is Newton per meter squared. So 1 Pascal is equal to 1 Newton per meter squared. We normally talk about pascals in kilopascals because Pascal is a very small unit. Okay, just kind of a heads up as you go. Okay. So obviously, the smaller the area, the larger the pressure, right? So you have the same force acting on a large, if you have it on a large one versus a small one, the pressure is going to be different. Okay. Okay, so we have discussed that. So let's flip the page. Pascal's law. Pascal's law. Pascal's law states that for a fluid at rest, pressure at a point is the same in all directions. Note carefully that we're discussing pressure at a point. Okay, in other words, if I have a tank of water, or a tank of any liquid for that matter, right? And if I have an object here, a point, the pressure that is being exerted on this point is going to be the same, right? Because it's going to be at rest, right? It's going to be at rest. It's not going to go anywhere, right? So if it's at rest, that means that the forces are balanced, right? So the pressure is going to be the same at all points. The pressure is calculated if this is H. Okay, the pressure at that point is going to be equal to rho GH, where rho is the density of the liquid. Okay, and then G is the gravitational constant. H is the depth, right? So when a submarine dives, right, okay, when it dives, it goes underwater. They go down to, there's a max depth that you can go to, right? If you go too far down, what happens?
Crushed.
You get crushed, right? It implodes, right? Not explode, but it implodes, it gets crushed, right? So we have submarines, there's a max depth that you can go to, okay? There is a test depth, okay, where it's actually been tested down to a certain point, okay? And then there is the all crush depth, right? Crush depth is where you go there, you're not coming back up. Okay, so in the Navy used to say that if you're in a submarine, you always want the number of goings down be equal to the numbers of coming back up, okay? If not, you got a problem. So that's the pressure here. But the true pressure here, obviously, is there's also, what, up here, there's all the atmospheric here is too, right? So you actually have the pressure of the atmosphere coming down on here. So the true pressure here is going to be rho GH plus the atmospheric pressure at that point. Okay, and the atmospheric pressure at that point is going to differ on what your altitude is at that point, right? If you are higher up, and like Mount Everest, are you going to have less or more atmospheric pressure? Less, right? The closer you come down to the sea level, atmospheric pressure is going to go up, right? Because you have a larger or a longer cylinder of air pressing on you, right? So that is located, okay, down there. So if you look at the page 316, there is equation 10.15. And we talked about that. And then we talked about the gauge temperature, the gauge pressure, where P sub B is on that. If you look at the bottom picture there, it says P at B is equal to rho GH plus the atmosphere. We talked about that. Okay, and then there's, let's go ahead and we'll talk about this guy here, example 10.8. You know what? We'll do that later. Let's go ahead and call it let's go ahead and cut this off right here.